Okay, we're ready to begin our tech talk today on editing machining data libraries in NX CAM. Questions will be answered live at the end, but please go ahead and enter them into the chat as they come up. Our presenter today is Yahia Khan. He has over 6 years experience in aerospace manufacturing industries, specifically on CAM programming and CNC machining. Throughout his career, he has worked as a CNC machinist, a CAM programmer, and a manufacturing engineer, and is currently working at PROLIM as an NX CAM application engineer in our Cincinnati location. Welcome, Yahia. The Tech Talk is now yours.
Hello everyone, welcome to PROLIM Tech Talk. Today we'll be talking about editing machining data libraries in NX CAM. Well, this is a very short topic, but again it's very useful. You can predefine your speeds and feeds with the help of machining methods, tool material and part material. Let's go ahead and take a look at our NX and see how we can edit those data libraries, and as well as how to locate the files that are saved inside the NX directory. So here I do have a part opened up which has a various operations created, and it does have the three mill methods, including some drilling operations as well. So you can see your edit machining data libraries inside the home tab. If you can also see some drop down here, and if you cannot find the ribbon bar for some reason, you can go ahead and search it in the search command on the top right corner. You can type edit machining data libraries, and NX will show you the suggested commands for that. And if I open it up, so this is the main dialog box of the edit machining data libraries. It comes with the 6 different tabs on the top. The first one, what you see here, is a machining data, where you can specify the 3 filters that I spoke about: the tool material, the cut material, and the cut method, and the part material. So to find a full speeds and feeds for a specific data, you need to choose the filters for which tool material and for which cut method and for which part material you are defining those feeds and speeds. So there are some out of the box feeds and speeds available with the available material and the tool parts over here. So you can even create your own tool material and part material, as well as the cut method, where if you want a dedicated stock to be left on your part, for an instance, the mill rough method that comes with the NX installations, usually it's in the like 1 mm stock on the part, whereas if you are in the inches, then it should be around 30 thousandths. You can even change it depending upon your application. So you can also create your own methods over here, just to, if you have any custom stock that has to be left on the part, and you can use that as a filter over here to define the feeds and speeds. Well, there are also cut method. You can also create the cut method here, and tool materials, part materials, and these are the machine kits that are available with the NX. But if you have your custom machine kit installed, you can see that in this list. And the main purpose of this machine is because it NX calculates the feeds and speeds with the help of this rigidity option, what you see. So the maximum value of rigidity can be entered is 1, and the minimum should be, from 0 to 1. So it should be less than 1. If you enter more than 1, it doesn't consider in the feeds and speeds, or it will throw you an error over there. So these rigidities, basically, if you have older machines, and that older machines can lead to more tool deflections, right? So with the help of this rigidity, you can scale your machine's health. If it is too older, then you can specify the rigidity to zero point 0.5 or 0.3, and X multiplies the feet and speeds with the rigidity value to give you the lesser feeds and speed based upon the actual feeds that are predefined. So it will help you to give the optimal speeds for the older machines, or the depends upon the rigidity what you have entered over here. So let's go ahead and create a tool material and a part material. So let's go ahead and create a new part material. As I said, we can go to our part material tab over here and we can insert a new material. So let's create a titanium 6% of aluminum and 4% of vanadium. It's Ti6Al4V. So I'll keep the code as same, and the name should be like titanium grade 5. Description, you can see high strength, titanium alloy. Okay, and hardness you can specify depending upon the HRC value. Let's give a 35 HRC for now. So now this material has been created, so we can also let's also create a tool material, and let's start with creating the library reference name. So let's give it a carbide titanium carbonitride. Okay, and name we can give carbide with TICN coating. Let's click OK to this. So we have our carbide tool created. So let's go to our machining data, and if you see, it will predefine those two newly created tool material and part material. It automatically selected the carbide and also selected the part material. So what we can do is we can select the cut material based upon the application what we need. So let's go ahead and select our cut method as finish, and we can go ahead and insert a machining record. So for the library reference, let's give a unique name. So we are saying it's finish with titanium 6 and using titanium carbonitride coated carbide and mill. Okay, and let's say I have a proven feeds and speeds for a specific diameter cutter using these two filters, one with the part material and one with the tool material. So I'll say I have a 6 diameter of the end mill, and the cutter length that I have used is a 50 mm, and the cut depth is 300 microns, and the step over is 200 microns. And now the surface speed that I have used is 35 meters per minute, and depending upon that it automatically calculates the spindle speed. And let's give a feet per tooth of 0.045, and the cut feed rate is calculated automatically. And this flute length, I guess it's let's say for the finish, I guess 6 flutes, depending upon the uh, you know uh, the end mill over there. And for the feed rate percentages, if you keep it to 0 for the approach, it'll use the rapid moves. For the engage and the first cut, if you keep it to 0, it will uses the 100% feed rate. So I'll say approach as 0. Okay, I need 100. I need the rapid for approach, and for the engage I need 90%, or maybe I can keep 100%. And first cut, I always need lesser feed just to engage into the material. And step over, I can keep it 0. That's fine, it will take the 100% of the cut feed rate. And retract and return 0, everything is good. So if I click OK to this, and my library reference has been saved, and if I say apply, that gets saved, and you can add your own additional tool material and part material. And if I go back by clicking OK, and if I change my workpiece material from the carbon steel to the titanium TI6L4V that we have created, and if I click OK to this, and let's go ahead and let's go to our machine tool view, and let's see what we have. We need to track down the finish, which is finish pocket. So let's change the material of this tool. Currently it is defined as HSM end mill inserted. We can select our carbide with titanium carbonitrate coating, and now if you see, the length is 75, and flutes with the 2 flutes are defined here. So let's click OK to this. If I go to my Z level profile operation, and if you notice here, the maximum distance that has been set before is 10% of the tool diameter, and the feeds and speeds that are defined here are using the previous tool material and the part material. So now, since we have changed it, if I click on this set machining data, it will change the surface speed based upon what we have entered, and this 100 cut feed rate comes uh, with the calculation of the tool diameter what is currently present. So if I go back to my main, you see the depth per cut is also changed to 0.3, and you can create a lot of machining records with the wall machining or floor machining by predefining some depth per cut, and all those kind of different parameters. So now if I show you another functionality of the edit machining data libraries, by the way, you can also access edit machining data libraries from this ribbon option. So if you don't see the edit machining data libraries icon here, if you drop down this little black arrow under the tool group, you can select the you can see all the options which are available, and if you check this tool group, you will be able to see this post configurator drop down. If you select on this, you can be able to open the edit machining libraries. So let's see, for the pre-existed machining data library, if I say if I go ahead and see here, I have 6 diameter record with the 18 mm length, which has a predefined cut depth and step over. Whereas if I go little further down, it does have another 6 diameter tool, but the length is like 30 mm for this, and it has a different cut depth and step over. So whereas it says 18 length and 30 mm length, so let me go ahead and change my tool material to the HSM ball mill with TIALN coded, and let me also change my part material to HSM P20 pre-hardened. So if I go ahead and check my tool parameters, I have 6 diameter, but the length what I have here is 100 mm. So if I go ahead to my Z level operation, and if I regenerate my feeds and speeds, so if you see here in the maximum distance, it says 20 micron depth per cut. So this is basically coming from the NX interpolation method for the records. So let me show you again. So the NX is trying to interpolate between the parameters of 6 diameter cutter with the 18 mm length and the 6 diameter cutter with 30 mm length. So it will interpolate between these two different sizes, and with all these parameters it will try to calculate on the basis of percentage. So let me just take a snapshot of this to show you the difference, and let me open my NX. Now it says 20 micron, right? So if you see over here, it drastically changed the depth per cut from 0.28 to 0.02 because my length of my cutter is 100 mm, so it's eventually too much high, and NX knows that there will be a lot of tool deflection because of the length, so it has reduced the feeds and speeds based upon the available records inside our machining data libraries. So that's how you can predefine your feeds and speeds. And the other option that I wanted to talk with you is where all this data is gonna be saved, right? So if you go to your NX installation, in my case it's installed in C drive under program files, and if you have saved it in your custom location D drive or F drive, you can go to the mark resource and library. So under library you can find the feeds and speeds. So inside the feeds and speeds there are two different folders, in class and ASCII. So inside the ASCII folder, so you'll find all these cut methods, machining data, feeds and speeds. So if you open the machining data.dat file, you can see all these records that has been saved in this .dat file, and you can also see that we do also have our custom created finish feeds and speeds records that I have created while demonstrating. So by using this mark resource library and feeds and speeds, you can copy this machining the entire feeds and speeds folder and paste it to your custom location where all your organization is looking at. So by this, all other users in your organization can use your predefined feeds and speeds. Well, so that's all what I have to show you. I hope you liked it, and if you have any questions, feel free to ask. Thank you so much.